Hey, what's going on, guys? This is my 7th video on complex numbers. I have shown you guys in my previous video I was doing some multiplication and division. Here I'm going to continue the complex numbers. Let's say we have a problem like, let's say we have something given like this: 3x squared plus 4x plus 7. How can we solve this? That is, let's say this is equal to 0. How can we solve this? And whenever we have a quadratic formula, we have to see whether it's simply factor or is it a perfect square. To see whether it's a perfect square, what you have to do is you have to multiply these two numbers. You will get 21. 3 times 7, 21. Now you have to see whether multiplication of any numbers like 21, when you multiply, let's say we have numbers like negative 1, or let's go positive. Okay, 1 times 21 is 21, and the difference between them will not give 4. We have to see whether the difference between them give 4. And also we have another possibility that 3 times 7 is 21, but 3 times 7 is 21. Actually, when we add them we have to get 4, but 3 plus 7 gives us 10. We cannot get that. But there's a possibility we can have that minus 3 plus 7 gives us this number 4, but it's not gonna give us positive 21, because when we multiply 3 times 7 we are getting positive 21. We have to get positive 21 when we multiply, but here we will get negative 21, so it's not possible. It has to be negative 7 or negative 3, and if we get 4, it's possible. So since we are not getting any numbers that add up to 4, this is not a perfect square, so we have to use a quadratic formula to solve this problem. And we know that let's see whether it's in the standard form. In standard form, the quadratic formula looks like this. Form should be looking like this: ax square plus bx plus c, and this is already in that form. Now we can put it in the quadratic formula, that is x is equal to negative b. Okay, my mouse is loading. X is equal to negative b plus or minus square root of b square minus 4ac, okay, divided by 2a. In our case, a value is 3, b value is 4, and c value is 7. So we just have to plug those values in this equation. Negative b value is 4, and plus or minus square root of b square, that is 4 square, minus 4 times a is 3, so 4 times 3 times c, that is 7, divided by 2a. And let's 2a, okay, 2a value is 3. I can put that one right here as well. 2 times 3. Now let's simplify this one. Negative 4 plus or minus 4 square is 16, 4 times 3 is 12, times 7, and then divided by 2 times 3 is 6. Now 12 times 7 is 84, so negative 4 plus or minus square root of 16 minus 84, the whole thing divided by 6. Okay, I divide here because I'm moving down all the way. I moved all the way down. Now let's continue here. Okay, now I'm going to continue right here. Now minus 4 plus or minus square root of 16 minus 84. 16 minus 84 gives us negative 68, divided by 6. And now the next thing we have to see is whether we have a multiplication of this number is a square form. We can simplify this one into 4 times. Okay, 4 is a square number. Like, square number is basically, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. So we have to see whether we have a square number multiply that gives us 68. Here we can take 4 multiplication, and also 17 gives us 68. 17 times 4 is 68. and also we have a negative number, so -1. This is a negative, so I take -1 alone, because if we square it in -1, that's going to give us I, so we can just get rid of this one as I, and divided by 6. Now we will finally end up with -4 plus or minus square root of 4 is 2, and then square root of 17 remains the same, and then -1 we just put it as I. Square root of -1 is just I, and 6. Now we can write it in a standard form. Standard form of a complex number is a plus bi. So a is just a number, so -4/6, that's just a number, and plus or minus 2 square root of 17 divided by 6 I. Now this is in a standard form, but we can simplify this one furthermore, like -4/6 become 2/3, plus or minus here this one 1/3. We can get rid of, we can eliminate just like we can neglect 1, so square root of 17 divided by 3 I. Here we have two answers, that is -2/3 plus square root of 17/3, and -2/3 minus square root of 17/3, and don't forget the I. Okay, that's our final answer. Now let's look at another example like this. Yeah, I get rid of the whole thing. Now let's say we have a number given like this. We have an equation given like this: 2x square minus 3x plus 9. Again, 2 times 3, 18. If you see, any number of 18 factors doesn't add up to -3. You can try different numbers, but it will not give us -3 when you add them. So this is not also possible. This is not a perfect square, so we had to put it in the quadratic formula. X is equal to -b plus or minus square root of b square minus 4ac divided by 2a, and then minus, here in our case b is -3, so -3 right here, and then plus or minus square root of b square, that is -3 square, minus 4 times a is 2, so 2 times c is 9, and divided by 2a. 2 times a is 2. Now -3 is +3, plus or minus 3 square is 9, and minus 4 times 2 is 8. 8 times 9 is 72, divided by 4, and here we can simplify this one furthermore. Plus or minus 9 minus 72 is -63, divided by 4. And now what we have to see is, we have to see whether we have a multiplication of, if this one is a square number, like 1, 4, 9, 16, 25, any number multiply gives us 63. Here 9 times 7 gives us 63. That's the maximum number. We have to see, look at the biggest number. Okay, 9 is the biggest number that multiply by 7 gives us 63. So we can use that here. 3 plus or minus square root of 9, square root of 7, and also don't forget the -1, divided by 4. Now if we simplify this one, we will get 3 plus or minus square root of 9 is just 3, and then square root of 7, instead of square root of -1 we can just write it as I, and divided by 4. Now we can simplify, we can write it in a standard form, that is a plus bi form. If we write this one in a standard form, this 3/4 plus or minus 3 square root of 7/4 times I, and we cannot simplify this one furthermore, so we can just keep it as it is. So we have two answers: 3/4 plus 3 square root of 7/4 I, comma 3/4 minus 3 square root of 7/4 I. We have two answers, and that's it. Now let's look at another problem. Okay, let's get rid of all these things. Now let's say we have a question like this. We have a equation given like this: 2x times x minus 3 is equal to negative 5. So how can we solve this? First distribute this 2x to x and minus 3, so we are going to get 2x square minus 6x and then equal to minus 5. Now we can bring it into one side to bring it in a ax square plus, this equation ax square plus bx plus c is equal to 0. That's how we solved previous two problems. So we can try to bring it into that formula by bringing this negative 5 this side. That's 2x square minus 6x, or you can add 5 to both sides to make it this one 0. So we will get plus 5 here, and if you add plus 5, this one will become 0. And let's continue with this one. Now minus 6 we have in the middle. 2 times 5 is 10. Any addition of 10 numbers like 2 times 5, we can write it as what else, 1 times 10. Any addition doesn't give us negative 6. You can try different numbers, you will not get negative 6 when you add them. So this is not a perfect square, so you have to use quadratic formula, that is x is equal to negative b plus or minus square root of b square minus 4ac divided by 2a. In our case b is negative 6, so negative 6 plus or minus negative 6 whole square minus 4 times a is 2 and then c is 5 divided by 2a, 2 times a is 2. And let's simplify this one. 6 plus or minus square root of negative 6 square is 36 and 4 times 2 is 8, 8 times 5 is 40 and divided by 2 times 2, that's 4. Now let's continue here. 6 plus or minus 36 minus 40 is negative 4 divided by 4. So finally we will end up with 6 plus or minus square root of 4 is 2 and negative 1 in the square root, so square root of negative 1 is just I, so we can just write it as I 4. And now we can write it in a standard form, that is 3 over 2 plus or minus 1 over 2 I. Now so we have two answers, 3 over 2 plus 1 over 2 I, and we have 3 over 2 minus 1 over 2 I. So we have two answers, and that's it, we are done with this. Now let's look at another problem. Let's get rid of all these things and try another problem. Let's say we have a question like this. Let's say we have a question that's 6x plus 2y and that's equal to 18 plus 12y. If we have a question like this, what we have to do is we have to just simply solve for the x and y. And we know that whenever we have a complex number, that will come with this form, a plus bi, and a will be a real number. Real number means this is just a number, and b is the imaginary number. Imaginary number comes with I. So in our case, real numbers are 6x and 18, and imaginary numbers are 2i and 12yi. And if they are equal, then this 6x must be equal to this 18, and this 2i must be equal to this 12yi. From this one we can solve for this x and y. To do that, for the first one, what we have to do is we just try to divide both by 6, so we will just get x alone. So this is going to be x is equal to 3. So we solve for x, and here to find out for y, we have to get rid of this 12i, so we have to divide 12i both side, 12i both side. So this 12i cancels, and this will become just 1 over 6. So y is equal to 1 over 6. Now we have solved for x and y. Now let's try another problem like this. Let's say we have a question given like this: 3x plus 4i is equal to 15. Okay, my mouse is stuck here. I'm waiting it to respond. Okay, now it's working. 15 plus 16, this is equal to 16 plus 16yi, and as we seen before, the standard form of complex numbers comes in this form: a plus bi. A is the real number, bi is the imaginary number. Imaginary number always attached with an I. So in our case, the real numbers are 3x and 15, 4i and 16y are imaginary numbers. So this real number should be equal. Since they are equal, this real number should be equal. 3x should be equal to 15 and the imaginary numbers should be equal. That is 4i should be equal to 16y. Here if we have question like this, we had to solve for x and y. So to find this x alone, what we have to do is we just have to divide by 3 both sides. So this 3 cancels, we just get x alone, and here 15 divided by 3 just 5. So x is equal to 5. We solve for x. Here we have to find out for y value. This y is with 16i, so we have to get rid of the 16i. We have to divide both sides by 16i to eliminate this 16i and get the y answer. 16i cancels here, and here this is gonna I cancels and 1 over 4 remains. That's equal to y, and so we found out y value, and that's it. Now let's look at another problem. Let's say we have a question given like this. Let's say we have a question that's given x plus 4i and x minus 4i 4i is equal to 41. How can we solve this? And we know that when we have a conjugate in a complex numbers, we can simply multiply the terms like x times x and 4i times 4i, and we can neglect the foiling part, because when we foil, the middle term will go away. That's why when we have conjugate, we don't have to do too many things. We just try to multiply the first terms and the second terms and get the final answer, that is x. You can go ahead and try the foiling method and do it in a long way, but you will end up with the same answer I'm getting right here, that is minus 16i square. And here the 41 remains in the other side. So what we are going to get, x square, and we know that I square is -1, so -1 times -16, that's going to become positive 16 here, and here we are going to get 41. X square is going to be therefore 41 minus 16. 41 minus 16 is 25, so therefore x is going to be equal to square root of 25, that is plus or minus 5. So we solve for x. That's how we solve this one. Now let's try another problem. Let's say we have a question given like this. I use different color. Let's use this one. Okay, let's say we have a question like this. X is equal to, we have the values given and they are asking us to find out the equation. So x is equal to 3i and minus 3i. Okay, minus 3i. So if we have a question like this, what you have to do is we have to do the opposite thing. If x is equal to 3i, therefore x minus 3i should be equal to 0, right? We just move this 3i to the other side, so x minus 3i should be equal to 0. Like that, for this one, x plus 3i should be equal to 0. So we can write it like this. Instead of writing like this, we can combinedly write like this: x minus 3i, x plus 3i is equal to 0. Now we know that when we have a conjugate, here you can see we have x minus 3i, x plus 3i, so these are conjugates. So we can just multiply the first term and second terms. X square minus 3 square is 9, 9i square, that's equal to 0. Therefore x square minus 9 times x I square is minus 1, so minus 9 times minus 1 plus 9, that's equal to 0. Therefore we will get x is equal to -9. X square is equal to -9. X square is equal to -9, so x is going to be equal to what? 3i or -3i. 3i or -3i. Or we can just write it as plus or minus 3i. Right, now that's it for this one. Now let's look at the final one. I get rid of all these things. Okay, let's say we have a question like this. Let's say we have something x is equal to 4i. if you have just one value given, you have to know that when we have complex numbers, it doesn't comes as one, it has to come with a pair. So if it's just 4i, it means there's a negative 4i as well. So again we have to do the same thing. We have to equate it to 6.0, x minus 4i is equal to 0 and x plus 4i is equal to 0. We can combine like this and equate both of them to 0. Therefore we are going to get x square minus 16i square. Therefore, you know, since this is the conjugate, that's why I directly multiply x times x square minus 4i times plus 4i, 16i square, and I square is -1, so this is going to become x square plus 16. You can stop it right there. And in my previous one I made a mistake because x 3i minus 3i, they already given that. I don't have to go ahead and solve the final answer again. I had to just find out the equation. That's the question basically. So I don't need this part. I just try to find out the equation. X square plus 9 is the final answer. Here x square plus 16 is the final answer. I don't have to solve it again and come to the previous one. Okay, that was a mistake. So this is the final answer. That's it. I hope you guys find this video helpful. Thanks for watching. See you guys in my next video. I'm going to make more videos on complex numbers, and don't forget to subscribe my channel as well. See you guys later.